Hey guys, coming up here in a couple of weeks on the 31st, I'm going to be giving a workshop called Intro to the Phase Graph. And what I wanted to share with you today is that last night I finally made it through all levels of the Phase Invaders simulator without any errors. I've been working on this every day for the last few weeks, and I'm excited to demo it for you. So I just wanted to show you a couple of features right now, and hopefully it won't break in the middle of me showing this to you. So this is one of the more advanced levels that you would get to in the game, and it's intended to look more or less like your audio analyzer with a magnitude and a phase graph. And then there are just some DSP controls down here. You might think of it as being able to physically move one of the speakers, in this case the subwoofer. So here we're simulating a main sub-alignment, and I've got a magnitude and a phase graph, and I've got my sub on the blue trace here, and my main on the purple trace, and this teal trace here is the complex summation. It's the current summation if we were to turn these both on together and measure them, and this white dotted line is our target. Now, target isn't something I just invented. It's the maximum total possible summation we could get from these two traces. So it would be if you were just to add up both main and sub together, throwing phase out of the window. And the teal trace takes phase into account. But this is not where we're going to start the game. We're going to start the game actually just measuring a sine wave. So if I go to the very first mission of Phase Invaders simulator, then we can see that here we're measuring 1 hertz. And I think this is a great place to start because 1 hertz, a hertz means cycles per second, right? So we can if we measure 1 hertz, we can directly connect our time with what the movement that we see. So we know that if 1 hertz is 1 second, then we also know that 1 cycle of 1 hertz is going to be 1 second. So then we can start dividing it up and seeing the relationship between the phase graph and time. So here we're measuring 1 hertz, and I see that my sub phase is at 0 degrees, and my main phase is at negative 180 degrees. And because of that, my sum trace is totally disappeared. That's why I have a score of negative 2,600 right now, because I'm getting complete cancellation, right? I am totally out of phase here, causing a cancellation. So I've got no summation, just complete cancellation. So what do I need to do to change the phase of my sub measurement here so that it's in alignment with my main and I get maximum summation? Well, when we see a relationship like this, 0 to 180, the fastest way to get there is with a polarity inversion, right? So if I move that down, then we see my summation jumped here, it's on top of my target, and now I have a score of 100. But if we wanted to learn a little bit about how time affects phase, then I could grab this slider here. I could start moving that over. Let's move it all the way up to 20 milliseconds. And I can see that my phase measurement here barely moved. It's down to negative 7 degrees. Now, this is difficult to imagine because we don't normally measure 1 hertz, right? But if you imagine 1 second being the entire cycle all the way around 360 degrees, all the way around the phase wheel, then 20 milliseconds isn't that much. We need 1,000 milliseconds to get all the way around. So I'm going to set this back to 0. I'm going to say, okay, if I know that 1,000 milliseconds is all the way around the phase wheel, and I only need to go halfway around, then I'm just going to type in 500 milliseconds and see if that gets me there. And it does. It jumps down here, and now we have here maximum summation and a score of 100. So this is how you play the game. There's several different ways to do it. I've got a info bar up here that I haven't talked about at all, giving me, actually this will give me the answer to the game in a lot of cases. But I can also drag the slider around, I can type in the delay manually, I can invert the polarity, and when I'm done, I click sound check, because I'm ready for the sound check, alignment's done, and that'll take me to the next game. I don't want to go to the next game though, because I want to show you, instead of measuring a sine wave, what if we measure 3 points at once? So this game is called 80, 100, 120, and you can see that we have a point at 80, 100, and 120, but we don't have phase alignment. So I'm going to auto zoom so I can just see those 3 points really far zoomed in. Actually, maybe that's a little bit too much. So I'll take this down. Instead of 80 to 100, let's do like 50 to 189. There we go. Okay. This is a little bit easy to see. So you can see here that there's summation, but otherwise we're not getting much summation. We've got a really bad score. We've got these guys out of alignment. So how much delay do I need to add to get these down to here? I could just experiment adding some delay. Whoa, that moved a little bit too far, and then I could go back and see, and then I could eventually find it, and I could watch the summation here, and I could watch my score here until I found it. If I take this back to 0, I could also think about how much delay would it take at 80 hertz to go 120 degrees. So I can see that this is at 0 degrees and this is at 120 degrees. How much would that take? I could calculate that. So I could divide 1,000 by 80, get 12.5. I know that 120 degrees is a third of the way around the phase wheel at 80 hertz. So I could say 12.5 times 0.3, 3.75. Is 3.75 the right answer? I could put that in, and there they are, really close, right? Almost right on top of each other. I've got a really good summation here and a score of 99.41. Now if I were to reset this, I could also find the answer by putting my cursor on one of these points. So let's put the cursor at 80. Sometimes I can type it in, sometimes that doesn't work. And I can explain that later if you want. Okay, so if we look at 80, I've got a bunch of information up here, but what I'm really interested in is delta phase. So the difference in phase between the main and the sub at 80 hertz is 120 degrees, which this already calculates for me is 4.16 milliseconds. Okay, so if I put 4.16 milliseconds, perfect answer, I win the game, 100 degrees. I'm sorry, a score of 100. So I would hit sound check and go to the next game, but I want to jump back just to show you where you'll get to later on. So once you make it through all these levels and you have enough points, you can see your progress bar of points here, then you'll get into some predictions that I just generated with MapXT. So let's look at a UPJ and a 650p. And I'll hit sound check, so I'll go to that game. And this is kind of a mess, right? So let's zoom in just down to this area of interest. So let's say we'll zoom down to 400. Okay. So we're doing pretty good here already, right? Score of 92.48. This is the game that we started with. Our summation, predicted summation here is almost on top of the target. And this is because this game is UPJ and 650p coupled, two speakers right next to each other that should play together normally. But I can see here that the sub is not quite right on top of each other. And I know my sub is blue, so it looks like it actually needs to tilt up a little bit maybe to be on top of here. Let's try that. So I'll put in some negative delay. Now we don't have negative delay in our DSP, but you can imagine this is like physically moving your subwoofer, and that's why I also have feet and meters here. So I'll move this over 1 millisecond, which is like 1.1 feet or 0.3 meters. And you can see I have a better score now and almost perfect summation through the crossover region. All right, so those are three missions demonstrated with the Phase Invaders Simulator game, which we will be playing at the Intro to the Phase Graph workshop coming up in a couple of weeks. I put the link for that in the post for this video. You can sign up for that here. When you get onto that page, you can just go ahead and click Enroll Now, and I'll take you to the bottom here where you sign up for the class. So let me know if you guys have any questions about this. I hope that you think the game looks interesting and fun. I've had a lot of fun making it and even playing it. I've learned a lot from playing it for sure. And I hope to see you at the workshop.